Okay, this is part 3 of our notes from section 4.1 and 4.3. To be more specific, this is 4.3. Now, it brings us to this whole idea of mapping tables and graphs. Now, tables and graphs shouldn't be anything new. Whoops, where'd it go? Voila, there it is. Just trying to make it just a little bit bigger. So, in the example 2, it says express each relation as a table, as a graph, and as a mapping, then determine the domain and range. Alright, no problem. Now, it's really easy to graph it, especially when I give you a coordinate plane like that, so why don't we just knock out graphing? So the first point in this relation is 4, 3. So again, I start at the origin and I go over 1, 2, 3, 4, up 1, 2, 3. Did I go over 4? 1, 2, 3, 4, up 1, 2, 3. Alright, so I got a point there. And I have negative 1, 4. So I'm going to go over to negative 1 on my x-axis and go up 4. 1, 2, 3, 4. There's another one. 3, negative 2. I go to the right. 1, 2, 3, and I go down 2. There we go. That would be in quadrant 4. 2, 3, if this is my origin. 1, 2, up 3, 1, 2, 3. That would be in quadrant 1. And finally, I have negative 2, 1. I'll go over to negative 2 and go up 1, and that would be in quadrant 2. Alright, so we know how to graph it. Now to make a table, tables are really tough as well. So in a table, I'm going to have an x column, and I'm going to have a y column, and I'm simply going to write the ordered pairs in table form. The first one is 4, 3. Second one is negative 1, 4. Next one is 3, negative 2. Next one is 2, 3. And the last one is negative 2, 1. Alright, so now we've knocked it out as a table and a graph, and now comes mapping. Now mapping will be the new one. Now to do mapping, it just disappeared for some reason. Mapping. Alright, so to do a mapping, I simply start with my x, and then I have y here, and I'm going to make a very bad oval. Now, in the same way that we found our domain and range earlier, I always start with my x values, but I start from least to greatest. So now looking at this, it looks to me like 2 is going to be my lowest x value, so I'm going to start with negative 2. Sorry, negative 2 is my lowest. My next lowest would be negative 1. My next lowest would be 2, then 3, then 4. Now I'm going to do the same thing with my y values. Now, my y value, the lowest, would be negative 2. And then I would have 1. Then it looks like 3. Now again, just like we figured out our domain and range earlier, I do not need to put more than 1, 3, but I do need to put 4. Okay? So then to map, I simply start with this point. It says 4, 3. So I start with 4 in my x and I draw an arrow to 3. The next one says negative 1, 4. So I go to negative 1 and I draw it down to 4. Draw an arrow. Next one is 3, negative 2. So I go from 3 to negative 2. Next one is 2 to 3. So I come from 3 and go from 2 to 3. And negative 2 to 1. Now, it does start to look funky, but what I do notice is that 2 of the elements in my domain lead to the same range. Now, it's real easy to write domain and range then, so my domain is simply negative 2, negative 1, 2, 3, and 4. That's coming straight from my mapping. And then my range is negative 2, 1, 3, and 4. Now, I've represented the same relation 3 different ways, all right? Actually, 4 different ways, because I have it as a relation as a set of ordered pairs. I have it as a graphing, as a graph. I have it as a table, and I have it as a mapping. Now, this will conclude our tutorial, so you do not have a part 4. Actually, you do have a part 4. I lied. But before you go to part 4, I want you to... Ooh, what happened there? I want you to try these. So you have 3 to try yourselves. Now they say express it as a table, mapping, or a graph, and then write the inverse. Don't worry about this inverse quite yet, because we will talk about that in part 4. So table, mapping, and graph for each set. Once you're done with that, then go on to step 4, or part 4 of our tutorial.